Today on CSS Battle Breakdown, we will be covering Target 8, Forking Crazy. I am your host, Michael Dawson, and I'll be showing you how to complete this challenge. The CSS battles, if you want to try your hand at it, can be found at cssbattle.dev. On this site, you are challenged to use HTML and CSS to replicate images. You are not allowed any outside libraries, images, or other assets. You receive a score based on how closely you match the target and how little code you use. Even whitespace and comments will be counted against you. In order to complete this challenge, I will be using a simple 4-step process that anyone should be able to follow. The first step is evaluating the target. You must understand the underlying shapes and methods if you want to have any hope of creating it yourself. This step breaks the image down into simple shapes that can be replicated with HTML and CSS in an attempt to find the simplest method of completing the challenge. With that in mind, let us take a look at our target. Forking Crazy looks like a rounded fork. It has a lot more pieces than earlier challenges, which can make it intimidating for beginners. But if we take it one piece at a time, we can make the shape much more manageable. The first thing to consider is the background. It is a simple shade of light blue and should not cause anyone any troubles. Next, we will look at the main body of the fork. It is created out of a rectangle with a rounded bottom. You may think to use a circle, and that method would work, but it would require a lot more precision when making the tines. We can, however, let the top be rounded in order to reduce the arguments in our border radius, which would be the only location where the circle could gain any efficiency. This is only possible because the top is completely covered by the tines. The final thing to look at are the tines and the handle of the fork. They are all the same width and have the same shape. They each, however, have a different location, and the space between the tines is the same color as the background. You may have noticed that they all have at most one end visible. Thus, they only require one rounded end, but rounding both allows them to share a shape class without worrying about flipping or rotating them. We have finished our evaluation, and now we know how we're going to make our target. The next step is putting it together, and prove our hypothesis is in fact a valid solution. We will do this in the most simple manner we can, so that any mistakes are easy to spot and fix. We will start by making divs, which we will later style into the parts of the fork. We have 4 tines, 3 spaces between the tines, and a body, and finally a handle. Next, we will style everything, starting with the body. The body's only style is a light blue for the background. The next piece we will style is the fork body, because everything else will be arrayed around it. We want it in a specific position, so we set the position to absolute. Its color is the dark blue color from the palette. Its width is 35% of the canvas, and the height must be at least 100 pixels. We will move it to 150 pixels from the top and 130 pixels from the left. And the last piece is adding a 75 pixel curve to the bottom. Now we will move on to the first tine. I set it as a fixed position and changed the body to the same, since fixed is shorter than absolute and in this case will act functionally the same. The color is set to a dark blue and is given a size of 20 by 120 pixels with a border radius of 10 pixels to round the ends. It is moved to 130 pixels from the left to line up with the body, and set 50 pixels from the top. Next we will copy the first tine 3 times. We will be moving each tine 40 pixels to the right from the last one to properly place them on top of the fork. We will make another copy for each of the spacers. They get a light blue color and are spaced 20 pixels to the right of each of the tines. The final part is the handle. It is the same as the second spacer, but dark blue and moved down to 200 pixels. That gives us a perfect match, using 1776 characters for 600 points. You have probably noticed that there is a lot of duplications in this code. In fact, most of it was copy and pasted. In the third step, we will clean things up and get rid of all that duplication. A lot of the attributes in this code are duplicates. In fact, many apply to almost all the parts, and thus it is far easier to override the exceptions then adding the changes to each one at a time. Because of this, we will start by extracting as many properties as we can into a generic style using the asterisk wildcard selector to select for everything. The colors are split almost evenly between the elements, so there is little difference between extracting one or the other based on numbers. What does make a big difference is that the body would require a whole new style and cannot use another abbreviation without making the code longer. So we will extract the light blue color of the background to the wildcard style. Then we will go through the styles and remove the light blues from the spacers. All of the elements use fixed positioning, so we will extract the fixed positioning from the elements and move it to the wildcard style. The next thing we will remove is the width of 20 pixels. This applies to the tines, spacers, and handle, which means that only the body of the fork will need to override the property. Next, we will do the same for the height of 110 pixels. Then we will do the same for the 10 pixel border radius. The next attribute applies to all the tines and spacers. They're all 50 pixels from the top, so only the fork body and handle override this. That is pretty much all we can extract to the wildcard. Next, we will move on to the dark blue color. We will override this in its own block, which applies to the fork body, the tines, and the handle. Now, many of the styles have only a single attribute, so we will condense these so that they are easier to read. As we go along, we will combine the ones that have similar properties. The first is the first tine and the body, which are both positioned at 130 pixels from the left. The other is the second spacer and the handle, which are both 190 pixels from the left. Now, on the fork body, we know the top is hidden by the tines and spacers, so there's no reason it can't be 110 pixels like everything else. We will just move it up 10 pixels to compensate for the change. Now we add the handle to the color block because I forgot to add it earlier. Our code has changed quite a lot from the original code from the second step. We've gone down from 1776 characters to 781, about a 66% reduction. Our score, however, has not made such a grand change, only going up by 0.23 points to 600.23. Now it's time to see how much we can trim off and how much we can get that score up. We will start by changing the body to a paragraph with a custom attribute of B, which stands for body. This shifts the body down a bit because a paragraph has a 14 pixel margin, so we will remove all margins in the wildcard selector. We will now do similarly to the tines. These are given the attributes Z, X, C, and V, which are just the bottom line of letters on the keyboard in the same order as the tines appear. For the spacers, we use the top line of letters Q, W, and E, otherwise they would clash with our B, which already points to the body of the fork. And following that convention again, we will make our handle H. Now we will remove some extra stuff that the browser will put in on its own, like that last set of closing tags. We also do not need all those PX units, since those are default, nor semicolons at the last attribute of a block, not to mention all that excess white space. At this point I was a little confused and wondering why my code is so much longer than my previous attempts. I go back to my previous solutions, and after a bit of comparison, I realized that it's using border color instead of the less specific border, which is a lot shorter. With that, we submit to find that once again, we have managed about a 66% reduction. We've gone down to 346 characters from 781. And our score got a substantial increase this time, going up to 614.79 from 600.23. That's it for Target 8. Sorry it took so long to get out, but it actually took me a few tries to get the video where I did not do worse than my original solve. I refused to put up something so low quality. Thanks to Marco Grazer for giving me the motivation to get through this. If you want to see more of these videos, subscribe to get notified when Target 9 goes up. If you found this interesting, or at least educational, give me a like so that I can get some love from the algorithm. I will put up a link to the playlist containing the series on the screen here if you want to view the rest of the series. Thanks for watching.